Welcome to Homework Lib.
Hi, so in this case, the short answer is that yes, we're going to have a buffer, but now we're going to see why. Okay, so we have mixed equal volumes of HCl that has a concentration of zero point 0.1 molar and tris in its base form. Tris in its base form, I'm going to label it as tris minus, so this is the basic form. And in this case, we have a zero point 0.2 molar solution. Okay, let's say that we mixed the same amount of each of them. So the amount of mole that we have added of HCl and tris minus, essentially what we're going to find is that the amount of mole of HCl is going to be equal to one half the amount of mole of tris minus that is present in solution. Why is that? Because the concentration is one half and we added one half of it. That's it. Okay. And in this case, since we mix equal volumes, the total volume is going to be equal to 2 times the volume that we added of each. But as you will see, we really don't need that in order to know if we have a buffer or not. Okay? So now, if we look at the chemical reaction that is going to occur, tris minus, the basic form of tris, it is going to react with HCl, and actually it is going to react with the H2O plus that is going to be present in solution, since you know that HCl, when it comes into contact with water, it is going to produce H3O plus Cl minus. Okay? And since that is a strong acid, it dissociates completely. So the reaction, it is going to generate tris H. This is going to be the acidic form of tris plus water. And now, if we look at our ice table, let's call this value equal to N0. We know that of the acid, we added one half of N0. Initially, we have nothing of the acidic form, and water doesn't matter because it doesn't enter into the equilibrium equations. The limiting reagent is going to be H0 plus, so minus one half of N0 minus one half of N0. At the equilibrium, we get, and over here, one half of N0. So at the equilibrium, we get one half N0, 0, and one half of N0. So remember that for us to have a buffer, we need to have a weak acid and its conjugate base. And in this case, we have the weak acid, that is tris in its acidic form. This is the weak acid. And we have also tris minus in solution, that is the conjugate base. So the presence of both of them in solution implies that we have a buffer, and that would be all. Now, if you want to do the calculation for the pH of this specific solution, well, luckily for us, we're not going to need the total volume, right? But let's just write down the full Henderson-Hasselbalch equation. So the pH is going to be pK plus logarithm of the concentration of the conjugate base, so concentration of tris minus, divided by the concentration of tris H of the acidic form. And we can write down those concentrations by simply dividing the amount of mole by the total volume. So I'm going to make this parenthesis a little bit larger. One half of N0 divided by the total volume. One half of N0 divided by the total volume. And what you notice here, both of these guys, they're the same number. So we get logarithm of 1. And logarithm of 1 is equal to 0. So the pH will be equal to the pKa of tris. That, if you look it up, I think is equal to 8.07 at 25 degrees Celsius. And that will be all. Thank you very much.